Welcome back. This is week 3 of Fire 102, Fire Behavior and Chemistry. I'm John P. Kelleher. We're now going to vapor pressure and vapor density. Pressure is defined as the application of continuous force by one body and another body that is touching. Vapor pressure is a measurable amount of pressure being exerted by a liquid substance, as it converts to a gas and exerts pressure against a confined, closed container. Molecules in a closed container are constantly circulating and colliding. Some molecules escape into the air and fill the area with molecules in a gaseous state, and this process is called diffusion. Know that. In the weight of a gas is lighter than the surrounding atmosphere, molecules will continue to escape. This process is called evaporation. Equilibrium is reached when there are as many molecules being freed from the liquid as there are being reabsorbed. Air pressure changed at different altitudes at sea level. The air pressure is normally 14.7 pounds per square inch, psi. However, air pressure will decrease as you go higher in altitude. Know this, vapor density describes the weight of a gas as compared to normal air. You'll definitely see that again. It's given a number, usually in pounds per square inch, psi. Gases that have a lower vapor density weigh less than the same volume of air, and that will tend to rise. An example is methane gas. It has a vapor density lower than that of air, and the methane gas will rise into the atmosphere. Gases that have a higher vapor density, weight more than the same volume of air, will tend to sink into lower lying areas. An example of that is propane. Propane has a vapor density greater than that of air, and it will sink. These gases with a lower vapor density, are more dangerous when they talk about hazardous materials, and we'll go into detail on that towards the end of the class, because they do not dissipate into the atmosphere and they stay low to the ground. Most ignition sources are located near the ground, and that's when they can combust. Hence, the propane gas is much more dangerous than the methane gas. BLEVE, you'll see one of those in your terms, and also we'll go more in detail on hazmat. BLEVE is the boiling liquid expanding vapor explosion. A boiling liquid expanding vapor explosion occurs when a vessel holding a liquid ruptures. This occurs as a result of the pressure being exerted on its sides. When the liquid it is holding boils and the resulting pressure exceeds the container's ability to absorb the pressure. Even a vessel containing a non-flammable liquid can rupture violently, sending fragments everywhere. And again, we can see BLEVE. We'll talk about BLEVE more often when we get to hazmat. And there are some pictures. And again, the definitions and our terms. Ignition. When a substance begins to heat up, it liberates gases that can burn. If all the necessary ingredients of self-sustaining chemical reaction are present, ignition will occur. Ignition is the point where the need from outside a heat application ceases, and the ability for the material to sustain combustion comes from the heat generation of the material itself. Know that. Again, I have a handout here about BLEVE. We'll go more in detail in hazardous materials, but there's a handout about BLEVE. If you guys want to see that, let me know. I can send that to you. And there's pictures of the container and the process of a BLEVE and what happens when it does explode. And also on the bottom, I also put what we call gases lighter than air. That means the vapor density is less than air. And how we use that, the mnemonic is the HAHA mice. HAHAMICE. Hydrogen, ammonia, helium, acetylene, methane, illuminated gas, carbon dioxide, and ethylene. These are all products that are lighter than air. So what's that mean? They go up into the atmosphere, correct? So we'll go more in detail later on when we talk about hazmat. Continue on, boiling point. All materials or matter exist in three forms. Again, solid, liquid, or gas. The pressure and temperatures affect the state of matter. 70 degrees Fahrenheit and 14.7 psi are considered normal. A change in temperature or pressure can cause a change in the form of the substance. An example, if water is raised, water being a liquid, is a temperature, if the temperature is raised to 212 degrees Fahrenheit, that will change from a liquid form to a gas. When water is lowered to a temperature of 30 degrees Fahrenheit or below, that gas turns into or liquid turns into a solid. Gases compressed into liquids under great pressure generate heat, and liquids that boil absorb the heat. There's another difference. Flammable and explosive limits. A combustible material must meet certain requirements before it can oxidize. The combustible material has different concentration of oxygen in order for it to combust. The concentration is described in terms of percentages. Combustion can only take place when the substance is in a form of a gas. The level of gases are described in percentage. Gases can only ignite when certain concentration of that substance are present in the air. If there is not enough combustible gas present, the mixture is deemed too lean to burn. If there is too much gas, the mixture is too rich. When the concentration of a gas falls into the range where it can ignite, it is said to be within its flammable or explosive limits. Know that. An example is gasoline in an engine. In the car's carburetor, or fuel injection, I should say, combines the proper mixture of gasoline as liquid, and air as the gas to ignite and to combust. Flammable liquids can change depending on its temperature. The limits can contract or expand depending on the surrounding condition. Specialized instruments have been developed to display measurements of flammable and explosive limits. So again, getting back to gasoline, is if you run gasoline with air, a liquid, if you put in too much gasoline and not enough air, that is too rich. It won't ignite. But if you have too much air and not enough gasoline, it's too air. Okay, the flammable liquids are too high. But when you get in that balance, that flammable range, it will combust, hence turn the engine spark. The spark plug will ignite that, hence the piston explodes, and then turns the engine of a vehicle. Okay, that completes week 3. Take care.